Hey Precalculus, I'm coming at you with another video. This is all about section 1.3, which is multiplying and factoring polynomials. Let's get to it. So check out number 1 as our first example. It's basically the directions state that you need to, I'm not in the right book, okay, express as a polynomial. They're basically saying simplify as much as you can, expand it. So just remember that the double distributive property or FOIL, whatever you want to call it, can work here. You're taking 2u times the u minus 4, and you're taking the positive 3 times u minus 4. Over here, it's just 4u times u, which is 4u squared, and then 4u times negative 2, which is negative 8u. You don't have to rewrite it like this to expand. I'm just showing it so that maybe it's clarified that everybody in the first is being multiplied by the total second polynomial. So this gives you 2u squared minus 8u. So this one's been broken free, plus 3u minus 12. All right, you still got this plus 4u squared minus 8u together. So now it's just a matter of collecting like terms together and combining them either by adding or subtracting. So 2u squared plus 4u squared is 6u squared. Negative 8u minus 8u is negative 16u. Plus 3u should be negative 13. And then you got negative 12 just hanging off by its lonesome. Express as a polynomial, just did it. All right. Number 3. Number 3 is different in that it's not multiplying but dividing. So the thing you got to know is that there's kind of a distributive property-esque thing that goes on with division, where it's if you've got multiple parts on top, they all get divided by the one quantity that's on the bottom. So I'm just going to rewrite this as 8x squared y cubed divided by 2x squared y, and then do the same thing with the second term. At which point we should probably just simplify the best we can using properties of exponents. We talked about that in the previous lesson. X squared over x squared completely cancels out. 8 divided by 2 is 4. Y to the third over y, it's kind of like there's a 1 there, so just take 3 minus 1. And you got y squared. I eliminated the fraction because there's only positive exponents. It'd be putting 4y squared over 1. Completely unnecessary. Here you've got 3 for 6 divided by 2. X cubed over x squared is just x, and those y's completely cancel out. You can't simplify that any further, so 4y squared minus 3x is your final answer. Number 9 looks a little bit different. There's some roots in there, no numbers at all. So let's check it out. So like I said over there, whenever you're multiplying like a binomial times a binomial, 2-term times a 2-term, you can always split it apart by saying, take this one times everybody in the second. I'll just rewrite it again. And then take this one right here, also times everybody in the second polynomial. So root x times root x, that's like root x squared. Or you could think about it as the two roots cancel each other out. A square root times a square root with the identical part inside, they're just going to cancel each other out. You could look at it over here as it's root x squared, which comes out to be x. So there's what's going on. You got root x times negative y, which is negative root xy. Note that the root doesn't disappear if the two insides aren't the exact same thing. Over here you've got plus root. We could call this yx, but I think it makes more sense to call it xy because it matches up very similarly, well, identically to that one. And then when you have root y times negative root y, you get negative y. Kind of the same reason why the root x squared became an x. Notice something? Middles cancel. Yeah, so you're just left with x minus y. And really, one thing I want to highlight with this particular example is that at the very beginning of the problem, you had root x minus root y times root x plus root y. You might remember this from like earlier classes where we talked about this thing called difference of squares. And the reason why they were even significant in the first place is that they always end up canceling their middle terms out, and then basically you're squaring the first term and squaring the last term to get the product of that. So it's kind of like we could have bypassed, 2 or 3 minutes worth of work there by just saying, hey, we got a difference of squares. If they're multiplied together, all you got to do is square the first, square the last, and slap a negative symbol in between them. Okay. All right. Number 11. Expanding a polynomial with a cube exponent. So here's a common mistake. Common mistake. Sorry, I don't know what that was. Anyway, you do not want to just apply the 3 on the outside to every part on the inside. This is not x cubed minus 8y cubed. Nope. What you need to do, because this by the way, it's because this minus in between works totally differently than the multiplication you saw in the exponents review chapter. You actually have to expand this by saying it's x minus 2y times x minus 2y times x minus 2y. And that's going to be vastly different than just x cubed minus 8y cubed. So how that looks is you pretty much just want to pay attention to the first 2 binomials being multiplied together and kind of just leave this one on the shelf. X times x is x squared. X times negative 2y is negative 2xy. This is negative 2yx, but again, I can use the commutative property to rewrite it like this because these two are going to combine. And then this is going to be negative 2y times negative 2y. It's a positive 4y squared. These two middles don't cancel. They actually combine to give you negative 4xy. All right, so we have expanded the first 2 binomials being multiplied together. We got this. Now we bring this x minus 2y off the shelf. And we do it all over again. Hopefully you guys can see that. Yep. So we're going to do x squared times x minus 2y. Yep. Whoa. Then we're going to take negative 4xy times x minus 2y. Then we're going to take plus y squared times x minus 2y. So this is going to be a really messy result, but we shall proceed. Keep going. X squared times x is x cubed. X squared times negative 2y is negative 2x squared y. Just keep things in alphabetical order. That seems like the natural order of things. Negative 4xy times x. That just bolsters the x exponent to a 2. And then this negative times a negative makes a positive 8xy squared. And then this will be xy squared. I'm going to put a 1 coefficient there just so that we know that if it combines with something that it has a 1 in front. And then minus 2y to the 3rd power. Oh, I just noticed something. This was 4y squared. So that should be 4y squared. So that should be 4y squared. And then this should be 4, and that should be 8. All right. These will combine because they're identical. They have to have identical variable parts to be able to add or subtract to one another. So this is negative 6 x squared y. These have identical variable parts, x, y, y, x, y, y. So plus 12 xy squared, and then minus 8y cubed. There's also this thing called an expansion formula that's probably listed in the back of your textbook. You might want to check it out just to see. It usually reads a little bit like this. 8 minus a minus b cubed, and then they just show you like, put your a term here, put your b term here, and then bam, that's what comes of it. So you might want to check that out. All right, so that's the basics of multiplying polynomials. I think I'll just jump into the factoring part of it now. Where is my eraser? So get a start on number 13. Eight x squared minus 17x minus 21. We're just factoring that polynomial. Okay. Now there's so many different ways to describe this. You could do the guess and check method, you could do AC method factoring, and there's probably a bunch of others that are floating around on YouTube that would be, maybe even like probably more helpful than me. But this seems to be a pretty steady way of going about, just doing it from the bottom up with how you learned how to do factoring. AC method says, all right, I'm not going to be able to do this with 3 terms if it's a quadratically structured polynomial. What I can do, though, is try to split up the middle into 2 parts that share something with both my A term and something with my C term. All right, and the connection is that what we want to do is find something that multiplies to 8 times negative 21, which is negative 168, but at the same time adds up to our middle term B, negative 17. I think you guys will be pretty familiar with this method of factoring. The other way is guessing and checking, but, let's try this to start with. So you're looking up factors for negative 168. We have factors here, negative 21 and 8. They add up to negative 13. So in this column, you might be kind of guessing and checking here and just trying to figure out who adds up to negative 17. Now this is actually pretty close. So what you might want to do is ask yourself, all right, are there numbers close to 8 and 21 that maybe could make this happen? So they need to be slightly farther apart. So maybe 168, does it divide 6? Does it divide 7? You might want to ask yourself questions like that. 168 divided by 7 should be 24 because this is 3 times 7. Yeah? All right. So 168 divided by 7 gives us, just to confirm it, bingo, 24. 24 minus 7 is 17. We need the bigger number to be negative in order to add up to negative 17. Now this is where the ball gets rolling down the hill. You now replace the middle with 24x plus 7x. You drop down your A and C terms, and then it's a matter of factoring by grouping. That means you take the first 2 together and you ask yourself, what do they share? And they share an 8x. That's what you're going to extract from the group and put it on the outside of the parentheses. You'll do the same thing with the 7x minus 21. You should have the same leftovers inside, though. If you don't, you certainly did something wrong. You can take out a positive 7, leaving x minus 3. And then your final move is to bring the outside terms, sort of your GCFs, to 1. And then these leftovers will be the remaining factor.